Hello, my wonderful computer science students. Welcome to our last lesson in Unit 2 on selection and iteration. In this lesson, we are going to be going over nested iteration and talking about how we can have a loop inside a loop. And we're going to just be tracing through some examples, and I'm going to be showing you some techniques on how you can evaluate these when you are reading them in your code. For right now, we're just going to stick on evaluating them and figuring out what they produce, what they print. We're going to actually use these and write nested iterations when we get into talking about two-dimensional arrays, which is going to happen later in the course. So right now, it's just all about tracing and some techniques you can use to help you do that, but then we're going to actually write them later on in the course. So if you're ready to go ahead and get started, grab your notes and get settled in so we can go through this material together. Okay. So a nested loop or nested iteration is when we have a loop inside of another loop. The outer loop controls the number of iterations of the inner loop. So for every single run of the outer loop, the inner loop is actually going to run completely. Nested loops are very commonly used to create patterns. So you're going to see some number patterns being created. They're used in matrices and two-dimensional arrays. And they're also used to compare elements from two different groups. Like if you are comparing two different arrays, sometimes you can use nested loops to compare those elements. Okay. But all of those talks of matrices, arrays, two-dimensional arrays, those are all going to come later. Right now, we're really going to focus on the pattern aspect and how to read the loops and understand the nested iteration that's within them. Okay. So here is what this looks like. So I have a nested loop here, and I have two comments showing you when we talk about the outer loop versus the inner loop, what exactly those mean. So you can see the outer loop starts here. Okay, it's blocked off right here, and the inner loop is blocked off right here. So the inner loop is completely inside the outer loop block. Okay, so the outer loop is controlled by the variable I, and the inner loop is controlled by a different variable, the variable j. So the outer loop and inner loop are going to use different variables in their loop headers. Okay. So you can see what I'm going to do here is I'm going to print off a pattern. Inside this inner loop, I have a print statements where it prints I equals and then the value of I plus comma j equals plus the value of j. So this is a way we can just print off what the values of I and j are as this loop kind of iterates through. Okay, so what is printed? We're going to go through this example with just a formal trace where we make a tracing table and we keep track of the values of I and j as we go through. So if I keep track of I and j, I start off with I equals 1. Okay, and this is a good way to evaluate loops, especially if some weird stuff is happening, you're not exactly sure what's going on. A formal trace is a great way to get started when you're stuck. So I equals 1, we start with the outer loop, and then we move to the inner loop. Because I starts as 1, 1 is less than or equal to 3, which means we enter this outer loop, and then when we enter that into the outer loop, we go right into the inner loop, okay, which says j is going to be equal to 1. Okay, now we're stuck in the inner loop. Okay, so we've entered the inner loop. Now we're going to be stuck here until the inner loop is false. So j is currently less than or equal to 2. So I'm going to run that print line statement. I equals 1, j equals 1. That's the first thing that's going to get printed to my console. Then I come up, I'm still in the inner loop, j increases by 1, and then I check my condition again because I'm in the inner loop. J is still less than or equal to 2, so I'm going to print off this statement again. I equals 1, j equals 2. Then j is going to increase to 3. I'm going to check my condition, and my condition is false now. Now, since the condition is false, the inner loop is done. Okay. Once the inner loop is done, okay, I've reached the end of my inner loop, and then I've also reached the end of my outer loop, which means when I reach the end of my outer loop, I come back up here and I loop back around to the I++. I increases by 1. I is still less than or equal to 3. My outer loop is still true, so I'm going to enter it, and that means I'm going to start my inner loop again. Okay, so my inner loop gets started again, and j starts at 1 again. Okay, because remember, whenever we end our for loops, all right, so when I ended my for loop right here, my inner for loop, the variable j disappears from memory, okay? Because any variables that's declared inside my for loop, which includes inside the for loop header, it is a local variable only, so I can only use it inside the loop. Once I exit the loop, it's garbage collected and it's no longer in memory. So that's why when I enter in the inner loop again right here, what I'm doing, I have to redeclare it. Int j equals 1, and it starts off as j again. Okay. 1 is less than or equal to 2, so I print off I equals 2, j equals 1. J increases, so I'm stuck in that inner loop. 2 is less than or equal to 2, so I is 2, j is 2. J becomes 3, and then my loop gets broken because j, when it's 3, it's not less than or equal to 2. So my inner loop is done. I reach the outer loop, and that means I come back up here and I increase I again. Okay, increase I again. J is gone. And then I check this condition. Is I less than or equal to 3? It is in this case still. So I go back in one more time. J is 1. I is 3. J is 1. J increases. I is 3. J is 2. J increases, and then the inner loop is done. Outer loop, I'll increase I to 4, and then 4 is not less than or equal to 3. So the outer loop becomes false. Once the outer loop becomes false, then I'm done and I continue on with my program. My loop, my nested iteration has been completed. So what is printed to the screen? With this loop, nested iteration loop that I have, this is printed to the screen. So it shows how I and j is going to change. So notice how for each one iteration of your outer loop, your inner loop goes through a complete cycle. Okay, so the next time I increases to 2, your inner loop went through a complete cycle. I increased to 3, your inner loop went into and completed a complete cycle. Okay, so that's going to be the pattern for nested iteration. Okay. So if you see a nested iteration like this, you can trace through formally. Or, okay, you can start to use some of that brain power I know you have and do something a little bit different. So I'll show a different technique for the next couple of examples here. So they want to know, what do the following nested loops print? So this is a very common AP question where it wants to know basically what's the pattern that's printed. So normally you're given, on the AP exam, you're given choices about, is it A, B, C, or D? Which option, which pattern is printed as a result. So what we can do, because we kind of know for every one iteration of the outer loop, the inner loop completes a full cycle. We can start to talk about, okay, how many times is the outer loop and the inner loop each going to repeat? The outer loop repeats for the values of 1, 2, and 3 because it starts at 1 and goes up by 1, and it stops after I is equal to 3. So it goes 1, 2, and 3, and then once I reaches 4, it stops. So the outer loop is actually going to repeat 3 times. Okay? And then the inner loop, I can do that same thing. How many times? Well, the inner loop is going to repeat for values 1 and 2 because K starts at 1, it goes up by 1, and it repeats up to and equal to 2. So it's going to repeat 1 and 2. Okay, now what's going to be printed? Well, this time it's just going to be the asterisk that's printed. Okay, so what does that pattern look like? Well, that says the first time through, this is going to repeat twice. Okay, the first time through, the asterisk gets repeated 2 times. Okay, and then after that loop, I have just this print ln, open close parentheses. Remember, that moves the cursor to a new line. This just had print. So that's why I printed this, then this. Okay, I repeated that 2 times for that inner loop. And then once that inner loop is done, I move here, and that takes the cursor that's currently right here, and that moves the cursor so that it's now at the next line. Okay, and then after that's done, I reach the end and I loop back up here. So that was only 1 time of the outer loop. I need to do that 2 more times for a total of 3 times. So the next time through, okay, I do the same thing. I repeat the inner loop. Then I move to a new line, and then I repeat 1 more time for the inner loop, and now I'm done. Okay, so you notice I have 3 times here and then 2 times for the column here. I guess columns, if you want to think of it. Okay, 3 by 2. They're not always going to be such an even, nice pattern either. So I know you're thinking, oh, 3 times 2, it's going to make a 3 by 2. So if it's a 4 by 5, it's going to make a 4 by 5. And if you recognize that pattern, that is absolutely true. But sometimes it's a little bit trickier. Okay, like this next one that I have. Okay, so we'll see how many times the outer loop and the inner loop run. Okay, so the outer loop will repeat. When will it repeat? It will repeat for values of 0, 3, 6, and 9 for a total of 4 times. Okay, so I starts at 0. I increases by 3 each time it runs, and it goes up to but not including 10. So when I is 0, it'll run. When I is 3, when I is 6, and when I is 9. And then once I reaches 12, the loop will stop, so it doesn't run. So my outer loop is going to go 4 times. Okay, so already I know it's going to repeat 4 times. Inside here, K starts at 1. K times 3 is how it's going to increase, and I go up to and including 10 here. Okay, so what is that? That's K is 1. Then K is going to be 3. And then K is going to be 9. And then K is going to be 27, and it's not going to run. Okay, so the inner loop will repeat for values of 1, 3, and 9. So it'll repeat 3 times. Okay, so you always got to just be on the lookout for that. But now actually you know what's happening inside here. Well, you're just printing an asterisk again. And then after that inner loop, you're going to print a new line. Okay, so it actually does work as simply as 4 and 3, a 4 by 3. Okay, but let's see. Let's go through. The first time through the outer loop, we're going to run 3 times. Then we print a new line. 3 times, new line. 3 times, new line. 3 times. And then a new line gets printed, but it doesn't show up on the console, so you're done here. Okay, prints for a total of a 4 by 3. All right. You can also, of course, do a formal trace like we did with the first example too. There's nothing wrong with that. It is just more time consuming. And when you're looking at these on the AP exam, you want to be good about your time. Okay? But as you're just learning, there's no issues taking the extra time to do a formal trace as you're learning these, okay? Okay, here's a new one. I can see here that the print line statement, this time we're not printing an asterisk, we're printing the value of K. And then after the inner loop, I see that we go to a new line. So I see this pattern, right? When you're looking at nested loops, if you can see and recognize these patterns that you are starting to become familiar with, it's going to make the problems a lot easier. So let's go through and think about the inner loop and the outer loop and how many times they're going to run. And this time we really have to pay attention to what values, okay? So for this outer loop, we see that J is 4. And J loses 1 each time until J is greater than 0. So the outer loop is going to repeat for the values of 4, 3, 2, and 1. So it's going to repeat 4 times. All right. But now, do you notice what's happening on that inner loop? Not only am I printing off the value of K, but what does K start off as? K starts off as the value of J. So this is also something we can do in nested loops. Because J, remember J is a local variable to this block of the for loop, which means I can use J anywhere inside that block. Even though it's declared in the header as a local variable inside the block, I can still use it anywhere inside that block, okay? So now it's saying that K, when you enter the inner loop, K is going to take on the value of J. And J starts off as 4. Then the next time it runs, it's going to be 3, then 2, then 1. Okay, so that the inner loop will repeat depending on the value of the outer loop. Okay, right? So if I start at 4 here, then K increases to 5, and then I'm actually done because 5 is not less than 5, right? When K is equal to 3, then K would become 4, and then it would repeat again. Then it would become 5, and then end, okay? So the inner loop repeats depending on the value of the outer loop, all right? So the first time through, K is going to be 4, so you just print off a 4, okay? Because once K becomes 5, the inner loop is going to end. Then I print off a new line, I go back, and now J is going to be 3, so that means K is going to start off as 3. Okay. Now, when K starts off as 3, I'm going to print a 3, increase K to 4, print off a 4, increase K to 5, and my inner loop stops. So this is going to print off a 3, 4. Okay. Then I'm going to print off a new line, and then K is going to get the value of 2 because J goes to 2. And then you can start to see the pattern. I print 2, 3, 4. Okay. Print a new line, and then the last time through, K is going to be 1. Do you see what pattern is going to print? 1, 2, 3. Okay. These are very, nested loops are very pattern heavy. So once you can kind of figure out the pattern, you don't need to trace through every iteration of it. Okay. 1, 2, 3, 4, prints a new line, but then I'm done. The outer loop is done. It did its 4 times through, and that's the number pattern that gets printed off. Okay. Exciting stuff. All right, here's another one. If you wanted to pause, by the way, and try this on your own, see if you can get the pattern, what's printed off, go for it. Okay. I'm going to show you what this answer is. The outer loop starts at 8 and is going to repeat for the values of 8, 5, and 2. So it's going to repeat 3 times here, 8, 5, and 2. So I always like writing these off to the side so that I know what values J is going to take, especially because on this inner loop I see that the value of K is going to depend on what J is. And then here inside, what am I printing? I'm actually printing the value of J. Okay, so don't get that confused. Okay, K is going to be changing. K is actually going to tell you how many times you're going to loop inside, but you're printing J each time. Okay. So the first time through, K is going to be 8. So that means the inner loop repeats 8 times. The next time through, K is going to be 5, and that means the inner loop will repeat 5 times. Then K will be 2, and the inner loop repeats 2 times. Okay. If you like writing that off to the side to kind of keep track of how this loop is working, go for it. Okay. I've worked with nested loops enough that makes me feel the most comfortable to understand the problem. But if you're like, wow, Goldie, this is, oh, how do I know that? Go back to the formal trace. Make your table J and K. Say, okay, J starts off as 8 and then K starts off at 8. And then go through it. Okay. Go through it until you get more comfortable writing this off to the side, okay, and kind of putting it into words. Please do the trace. There's nothing wrong with that, okay? Do the trace. So what's going to happen here, since I know when K is 8, I repeat 8 times, and that's because J is going to be 8. So I print 8 8s, okay? And then I print a new line right here. And then when K is 5, I repeat 5 times, okay? And J is 5 at that point, so I do 5 5s. And then when K is 2, I do 2 2s. And that's going to be my nested loop. Okay. So they're like, think of these as like big puzzles you just got to solve. Okay. You got to figure out what's going on. You got to put the pieces together, put them in the correct order, and then it's just a puzzle, okay? Testing your problem-solving skills. And we are going to use nested loops when we deal with large data structures. So we are going to use nested loops. So it's important to know how they work and to get that problem solving ability of these down right now, because then it's going to help when we get to those data structures, okay? All right. This is the last example I have for you. This is a sample AP CSA question of what they could ask you. What output will be produced by this code segment? So they'll give you the nested iteration, and then of your choices, you just got to pick it. Now, luckily with multiple choice, you can do process of elimination, right? And I'm going to show you how to kind of do that. You probably already know how to eliminate in a set process, but it lets you, you can just start tracing through understanding what's being printed and eliminating choices along the way until you're left with the correct one, right? So I can see here, I'm going to start off. The outer loop will repeat for the values of 5, 4, 3, 2, 1. So the outer loop repeats 5 times, okay? The inner loop is going to depend on my outer loop, right? Because I see that J equals I in there, okay? So the inner loop depends on my outer loop, which is a good way to understand that you're going to have some sort of staggered table, okay? If I equals 5 and j equals 5, well, then you know you're working with like a 5 by 5 rectangle looking thing, right? But when I depends on j, you're going to have some sort of triangle, okay? Now, you don't always necessarily know off the bat how that triangle is going to look, but you know it's going to be some form of triangle. So technically, you could probably eliminate choice C at this point through just the process of elimination. But because we're just kind of learning about nested iteration, I don't expect you to know that off the top of your head quite yet. Okay, so let's go through. When j is 5, this is going to repeat 5 times. When j is 4, I'm going to repeat 4 times. Okay, remember, how do I know? Well, when I is 5, j is 5, j loses 1 each time. So j is 5, then it's 4, then it's 3, then it's 2, then it's 1. So it's going to repeat 5 times. When I is 4, j is 4, so it's going to repeat 4, 3, 2, 1. Okay, so that's how I know I'm going to have this pattern right here of the inner loop. Okay, and what's going to print? Well, I have a little math expression, yay, followed by a space. Okay, so what's the math expression? Let's go through. Well, when j is 5, when I is 5 and j is 5, what does that math expression print? 5 times 2 is 10 minus 1 is 9. Okay, so right out of the gate, I can eliminate D because the very first number printed is going to be a 9. Okay, then J becomes 4, right? J loses 1. So what is it here? So when I have this, J is 4, 2 times 4 is 8, minus 1 is 7. Okay. And then when J is 3, 2 times 3 is 6, minus 1 is 5. J is 2, 2 times 2 is 4, minus 1 is 3. And then when j is 1, 2 times 1 is 2, minus 1 is 1. Okay? And then that's my inner loop when j starts off as 5. I repeat 5 times, right? And then I print a new line. Okay? So all of the choices I have left, 9, 7, 5, 3, 1, 9, 7, 5, 3, 1, all of them have that as the first line. Okay? Notice the next line, though, I'm going to be able to start eliminating some stuff because when j is 4, when j moves to 4, I have moved to a new line. When this is 4, 2 times 4 is 8, minus 1 is 7. So 7 is the first number printed, which means I can eliminate A. Okay. And then what I said earlier, okay, about knowing the patterns too, when j is 4, it prints 4 times. So I'm going to have a number here, here, here. I'm not going to have a number underneath this 1. Okay. Then this repeats 3 times, then 2 times, then 1 time. Okay, so I know that I'm going to have a shape like B. C is not going to be the answer either. It's going to be B. Because of that, the inner loop repeating a staggered amount of times. You could also keep going and trace through, right? 3, 2, 1, and you can see that for yourself if you keep going, if you didn't notice that right away. Keep tracing through until you can narrow down and get the answer that you know it's going to be. Okay. And that's nested iteration for you. So exciting. So thank you guys so much for sticking along. If you have liked this video, please hit the like button and subscribe to my YouTube channel for more great computer science content. And that was the last video of Unit 2. So the next time I will see you is going to be starting in Unit 3. So I will see you guys then.